Hello, welcome to section 2.5. We're going to conclude this chapter by looking at measures of spread for data distributions. So let's just take a look at these three distributions. They're all symmetric and they all have the same mean. But can you see the difference? I think it's pretty clear. The red distribution is spread out more. The green distribution is a little tighter. The blue distribution is the tightest. This is what we mean by measures of spread. We're going to focus in this video on symmetric distributions. In the next two videos, we'll talk about skewed distributions. So with symmetric distributions, how can we measure how far spread out the data is? Well, one idea is to figure out how far on average is each observation from the mean. So let's just look at a very simple example. We have the numbers 1, 3, 5, 9, and 11. Their mean, in the sense of their ordinary arithmetic mean, is 5.8. So how far on average are each of these numbers from 5.8? Well, we subtract each of them. 1 minus 5.8 is negative 4.8. 3 minus 5.8 is negative 2.8, and so on. This gives us how far apart each of the five observations are from the mean of 5.8. So what happens if you average these? Pause this video for a moment and try and calculate the arithmetic average yourself. Okay, hopefully you paused and saw something odd occur. The answer was 0. That's indeed exactly what it means to calculate the mean, is all of your observations should their distance from the mean should average out to 0. So that idea, while noble, doesn't work. Let's try something different. The reason we're getting 0 is because the observations that are smaller than the mean have deviations that are negative that cancel out the positive deviations from the observations that are larger than the mean. But we can avoid that if we square all of the deviation, because a negative times a negative is a positive. So we square the negative 4.8. Draw your attention down to the squared deviation from the mean down at the bottom of the screen. We square the negative 4.8, we get 23.4. The next deviation is negative 2.8. If we square that, we get 7.84, and so on. So we found how far each is from the mean and squared them, and now when we average, we get something. There's one last annoying challenge, though. If these were represented real numbers, numbers out of the real world, and they had units, let's say these were the number of ladders at different fire stations in a county. Well, our squared deviations, that average is going to be squared ladders. Well, that doesn't make a lot of sense. So we need to get back into the units of the original observations. So to do that, we just take a square root of this average. That's the standard deviation. When you take the square root, in this case, you get 3.04. This tells us how spread apart we are. And the larger the standard deviation is, the more spread out the mean really is. So to summarize how we calculate this, we take each xi in this little formula. That's an observation. We find the deviations from the mean by subtracting, take all of those deviations and square them. Once we have all those numbers, we add them up and we average them. Now, for a technical reason, it has to do with something about degrees of freedom and bias and stuff like that. We actually have to divide by n minus 1 and not n. And then we square root the result. Now let's focus on how to understand that. And let's understand what this means in a context. Let's return back to return on investment. So if we have a distribution of returns on investment, then and we'll take a look at these three distributions. Ignore the numbers on the bottom because they're no longer realistic. But if you take a look at these three curves, the red one is more spread out. Well, what does that mean? That means you might get there's a higher probability of getting larger returns, but there's also a higher probability of getting much smaller returns. So that means the red distribution of return on investment is riskier. The green distribution is less risky, and the blue distribution is less risky still. So in the context of investments and return on investments, standard deviation tells you how risky a particular fund is. Well, let's look at an example using data over the course of 250 days or so, more than that, over the course of a full year for two different funds. But we're going to see how to use Excel to get our standard deviation, because this formula, this isn't something you want to do by hand. So let's go to Excel. So what we see in this Excel file is 280 some odd days worth of trading, and column B represents return on investments from Fund 1, and column C represents return on investments from Fund 2. We can see from the graphs they're approximately symmetrically distributed, so we can go ahead and think about means. I'm also ignoring the fact that returns on investment should be averaged using the geometric mean. We're going to use the arithmetic. But let's figure out the mean and standard deviation for each of these two funds and interpret what they mean. So I'm going to scroll to the bottom, and we've got 288 days. That's how many we have. So column B was Fund 1. So let's find the mean. Remember, we do that by typing average, and then we give the first cell and the last cell, and hit enter. So this gives us an average of about 11.46. And now let's do the standard deviation. So here's how you do how you get Excel to calculate standard deviation. You type STDEV, and there's a .P and .S. These are samples, so we use .S. That's what we're talking about as a sample standard deviation. So we type in same, otherwise it's exactly the same, B2 through B289. We don't want to include the mean. And apologies for some things changing. I actually generated these from a random number generator from a normal distribution, which is why they keep changing, because that's so. So we've got the mean, the standard deviation for Fund 1. We're going to get the same for Fund 2. Apologies for the data changing. And now we'll interpret the results. For Fund 1, the mean is set 13.417, and for Fund 2, it's approximately 13.106. So the means are very close. Those are percent. Think about those as percentages. So for Fund 1, the average daily return is 13.417%, which is a very high return on a daily basis. So maybe I need to fix that. But for now, let's go with it. And for Fund 2, it's very, very close. So the means are more or less the same. If you take a statistics class, you'll actually learn techniques called hypothesis testing to determine whether or not they are sufficiently significantly different in order to conclude they're really different. Here, we conclude they're not that different. So they're more or less the same, subject to some sampling error. However, look at the standard deviations. The standard deviation for Fund 1 is 15.4, and for Fund 2, it's 10.1. What that means is Fund 1's distribution is much more spread out than Fund 2. That means Fund 1 is riskier and Fund 2 is less risky. Since they have the same mean, then you'll likely go with Fund 2. To summarize, for symmetric distributions, we typically summarize those distributions with two values: the mean, which tells us where the data is centered, and the standard deviation, which tells us how the data is spread around the mean. In the next video, we're going to look at what we do with skewed distributions.